We live? There we go. Why does it take? Why is there such a delay? I don't know. All right. 2.4 practice. Good morning. Good day. It is. I'm cleaning my room today. And also I feel a little sick, but don't worry, you won't catch anything through the TV. That's a joke, because you knew that. Yeah. Alright, 2.4 was a concept called, clearing fractions. Like I said, never heard of it before, but I get the concept. It's just a way to get all the fractions out of the way in the beginning so that we don't have to deal with them later in the problem. We're going to be doing pages 61 and 62 evens, and it looks like it's a shorter lesson than the one we did before, so that's fine. And I'll just run through these like usual, going through my thought process, follow along, and yeah. All right, here we go. Starting with problem 2, we got x minus 1/2 equals 8. So there's only one fraction here, so we would be able to do it pretty easily going our normal method, but let's get in the habit of clearing fractions because you never know how complicated or not it's going to get later. So let's look at all the fractions. We only have one. What's the denominator? 2. The others are technically, there's an invisible one, remember? But 2. So what's the least common multiple of 2 and 1? It's 2. And just now I'm realizing I'll make a supplemental video for finding least common multiple and least common denominator so that it'll help you out. So keep an eye out for that video. Yeah, so we want to multiply both sides by 2. So remember how we do that? Am I in frame when I lean like this? I'm not. Ooh, hold on. Sheesh, I just realized a whole bunch of my picture was out of frame. I hope it wasn't like that for the last video. Okay. Carrying on. Alright, x minus 1/2. Okay, so we want to multiply both sides by the least common multiple, which in this case is 2. Am I in frame this time? Yeah, that's the problem I wanted to fix. Just had to leave the computer. Why am I sitting so weird? Ugh. Okay. That should work. That should work. Okay. So we want to multiply both sides by 2, and we want to do that by first rewriting everything and putting them in parentheses. So rewrite the left side, minus 1/2, put it in parentheses, equals 8, put it in parentheses, and now, like I said, we're multiplying by 2. 2, 2. And now we got distribution going on because we have a coefficient outside of our parentheses, and distribution works like multiplication. So let's start with the left. Remember, we're going to multiply our 2 by each term, so x and negative 1/2. So what's 2 times x? 2x. What is 2 times negative 1/2? Well, we can treat it like a fraction. Cancel, cancel. We're just left with 1, but because of the negative, it's negative 1. Now on the right, we got 2 times 8 is 16. Great, we know how to solve this problem. Reverse Pemdas, start with addition, subtraction. What's the opposite of subtraction by 1? Addition by 1. What we do to one side, we'll do to the other. Cancel, we're left with 2x. 16 plus 1 equals 17. 2x equals 17. What's the opposite of multiplication by 2? Division by 2, divide by 2. What we do to one side, we do to the other. Cancel, cancel. We're left with x. 17 over 2 have no factors in common, so we'll just leave it as that fraction. Woo! All right, 5 over 8 plus c equals 1 1/4. Two things going on here. One, we want to figure out which denominators we have in all our fractions, so we can do the clearing of fractions. So we got an 8 and a 4. What's the least common multiple between 8 and 4? It is 8. So we will be multiplying by 8. However, notice, what is this? That is a mixed number. We like to work with improper fractions over mixed number. So let's start by converting that. So rewrite the left plus c, because all we want to do is change the right. 4 times 1 is 1, added the 1 gives us 5 over 4. Now, let's multiply by our least common multiple, 8. We'll rewrite everything on the left, plus c, put the whole thing in parentheses, rewrite the right. What's left on the left, rewrite the right. Ha ha ha, wordplay. Put that in parentheses, we're multiplying by 8. We're multiplying by 8. Let's go ahead. 8 over 1 times 5 over 8. The 8's cancel. We're left with 5. And remember, we are multiplying by 8 again to the next term. 8 times positive c gives us 8c. On the right, we can treat it as 8 over 1 times 5 over 4. We got 4's in common on the top and the bottom. 4 goes into 4 once, 4 goes into 8 twice. 2 times 5 is 10. Bam, we got our basic algebra problem. So what's happening to C? It's getting multiplied by 8 and added by 5. So since we're undoing, we're going to do order of operations backwards. What's the opposite of addition by 5? Subtraction by 5. What we'll do to one side, we'll do to the other. These cancel, we're left with 8c. 10 minus 5 gives us 5. What's the opposite of multiplication by 8? Division by 8. What we'll do to one side, we'll do to the other. These cancel, we're left with c equals 5 over 8. And because, yeah. All right, next, 4 over 11 plus s, that's an s, equals 9 over 22. Let's get rid of our fractions. What are our denominators? 11 and 22. What's the least common multiple between 11 and 22? It's 22. So we'll rewrite our left, put in parentheses, multiply by the 22 on the outside, rewrite our right, put our 22 on the outside. 22 over 1 times 4 over 11. 11 goes into 22 twice, 11 goes into 1 once, 2 times 4 is 8, and then remember we reset, so we have 22 again when we multiply by s. 22 times s gives us 22, positive 22s, and then we got 22 over 1 times 9 over 11. 11 goes into 11 once, 11 goes into 22 twice, 2 times 9 gives us 18. Basic algebra. We got s multiplied by 22 and added by 8. We'll start backwards since we're trying to undo everything. What's the opposite of addition by 8? Subtraction by 8. What we do to one side, we'll do to the other. These cancel. We're left with 22s. 18 minus 8 gives us 10. S is being multiplied by 22. What's the opposite of multiplication by 22? Division by 22. What we do to one side, we'll do to the other. These cancel. We're left with s. Before we bring down the 10 over 22, we can notice they do have factors in common this time. They're both even. 2 goes into both of them. 2 goes into 10 5 times. 2 goes into 22 11 times. We're left with 5 over 11. S equals 5 over 11. All right. Negative 3x plus 4x minus 2x equals 3 over 8. Now, we could do clearing of fractions, but if we notice, our left side doesn't have any fractions right now, and they're all x terms. So what do we do in this case? We want to simplify the left side. How do we do that? We can combine like terms. Since they're all x terms, meaning they have the x variable, they can be combined. So what's negative 3x's plus 4x's? 1x. And then what's 1x minus 2x's? Negative 1x. So we can actually do that step by step if we want. Negative 3x plus 4x gives us x. Rewrite everything we didn't touch. X minus 2x gives us negative x. All right. And negative x equals 3 over 8. What's happening to x? It's being multiplied by negative 1 is one way of thinking about it. What's the opposite of multiplying by negative 1, dividing by negative 1? Our negatives cancel. We're just left with x, but what we do to one side, we'll want to do to the other. What's anything divided by 1? It's itself. But because we're dealing with a negative right here, we can all we have to do in this case is flip the sign. So that's a neat shortcut. Whenever we're multiplying or dividing by negative 1, all we got to do is change the sign. Little shortcut. Okay, 11 over 2x equals 22. We could do our clearing, our fraction clearing, but in this case, since there's only one thing we have to do to the x, we'll go ahead and do that. What's the opposite? Multiplying by 11 over 2, multiplying by the reciprocal, 2 over 11. What we do to one side, we'll do to the other. Cancel, 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 cancel. We're left with x, and then 11 goes into 11 once, 11 goes into 22 twice, 2 times 2 is 4. Dang, that's a lot of 11s, and we're only doing the odds. How many was that? 1, 2. Okay, maybe it was just 2. But I thought there were more. Let me check. Wait, have we only done 5 problems? Oh, I thought I did so much more. Oh, well. Carrying on. Alright. 2 over 5x plus 5 equals 9. This is another situation. We've done problems like this before. When the fraction is just on our x term, we really don't have to worry about it so much. But we can still do fraction clearing if that's what you want to do. I can do this one both ways if you want, but we'll do fraction clearing first. What's the least common multiple of all the denominators? We only have one denominator, it's 3, so we'll multiply by 3. So rewrite the left, put in parentheses, put our 3 on the outside. What we do to one side, we'll do to the other. 9 in parentheses, 3 on the outside. 3 times 2 over 3 3's cancel, we're left with 2x, and then undo we still have 3 again. 3 times positive 5 gives us positive 15, and then 3 times 9 equals 27. Subtract by 15, we're left with 2x equals 12, and then divide both sides by 2, and we get x equals 6. Or, let me show you how we can do it the other way. Right now, x is being multiplied by 2 over 3, then added by 5. What's the opposite of adding? Oh, shoot. All right. What's the opposite of adding by 5, subtracting by... Ah! All right. Subtracting by 5, what we do to one side, we'll do to the other. Cancel, we're left with 2 over 3x. That's a 3, even though it doesn't look like it. Equals 4. What's happening to x? It's being multiplied by 2 over 3. What's the opposite of multiplying by 2 over 3? Multiplying by the reciprocal, 3 over 2. What we do to one side, we'll do to the other. Cancel, 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 cancel. We're left with x. And then over here, 2 goes into 2 once, 2 goes into 4 twice. 2 times 3 is 6. So either way, they both come out to x equals 6. But whichever method in this case is fine. This one seemed to work better. So yeah, whenever our fractions are only on our variable, we can just save it. We can just do it. We can just save fraction clearing for the end. So we'll do it that way. So x is being multiplied by a half and added by 17. What's the opposite of adding by 17? Subtracting by 17. What we do to one side, we'll do to the other. We're left, these things cancel. We're left with 1/2 x. 30 minus 17 equals 13. X is being multiplied by 1/2. What's the opposite of multiplying by 1/2? Multiplying by the reciprocal. Flip the fraction, 2 over 1. What we do to one side, we'll do to the other. 2 over 1 is the same as multiplying by 2. We're left by x on the left, and then 13 times 2 is 26. Great. 2 over 3x plus 5 over 6 equals 7 over 8 plus 1 over 3x. Great. We got lots of fractions in this one. So what are our denominators? 3, 6, 8, and 3. So really 3, 6, and 8. And we want to know what the least common multiple between all these are. Like I said, I'll look out for the least common multiple video, and I'll show you exactly how we can solve it for multiple denominators. But for right now, I'll just tell you it's going to be 24. Yeah, so we'll multiply everything by 24. And yeah, so what we do, per normal, we'll rewrite the left, put in parentheses, put our 24 on the outside, rewrite the right, put our 24 on the outside. Great. 24 times 2 over 3. 3 goes into 3 once, 3 goes into 24 8 times. 8 times 2 is 16. Don't forget about our x. And then do the same thing. 24 over 1 times 5 over 6. 6 goes over into 6 once. 6 goes into 24 4 times. 4 times 5 is 20. And then we got over here, 24 over 1 times 7 over 8. 8 goes into 8 once. 8 goes into 24 3 times. 3 times 7 is 21. And then 24 over 1 times 1 over 3. 3 goes into 3 once. 3 goes into 24 8 times. 8 times 1 is 8. Don't forget about our x, 8x. All right. It's been a while since we've seen one of these problems, but what we want to do is get all the x's to one side. So let's move our 8x over to our 16x. So we can move it, but because right now it's being added, it's adding 8x. So the opposite of adding 8x is subtracting by 8x. What we do to one side, we'll do to the other. We're left with 21 on the right, and then we didn't touch the 20, and then 16x minus 8x gives us 8x's. All right. 8 times x plus 20. We're working backwards, Pemdas, since we're trying to undo everything. What's the opposite of adding by 20, subtracting by 20? What we do to one side, we'll do to the other. These things cancel. We're left with 8x equals 1. And then the opposite of multiplying by 8 is dividing by 8. What we do to one side, we'll do to the other. We're left with x equals 1 over 8. All right. All right. 2 over 3x minus 3 over 4x equals negative 7 plus 3. Let's go ahead and clear these fractions. What's the least common multiple of 3 and 4? It's 12, so we'll multiply both sides by 12, rewrite what we had, and put them in parentheses. Oops. Oh, okay. Great. All right. 3 goes into 3 once. 3 goes into 12. 4 times. So if you notice, every time I've done the fraction clearing, the number on the outside has always been able to cancel with the denominator. Every single time. Here, 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 and then the other examples we did. Did I not do fraction clearing in this one? What? Oh, there it is. Here, that technically was a 1, so it didn't really matter. Here it canceled, here it canceled, here it canceled. So every single time, and that's by design, we're picking the number that will cancel with every single number. That's kind of the point of this fraction clearing. So we got 4 times 2x gives us 8x. Then take it back. 4 goes into 4 once. 4 goes into 12 3 times. And remember, we're looking at the whole term, so we got negative 3x. So what's 3 times negative 3x? 3 times 3 is 9. 9 times x is 9x. And don't forget about the negative 9x. Equals. And then these denominators are 1, so they don't help us at all. So we just got 12 times negative 7, which is negative 84. And then we got 3 times 12, which is 36. Great. All right, we're at this point. Let's simplify both sides because we can. 8x minus 9x gives us negative x. Negative 84 plus 36 gives us, it's going to be negative because our negative is bigger. I don't know, what is it? It's 48. If I'm wrong, you may let me know. All right, negative x equals negative 48. So what's happening to x? Being multiplied by negative 1, we can divide by negative 1. What we do to one side, we'll do to the other. And just like I said before, multiplying or dividing by negative 1 is the same as just changing the sign. So we're really just changing the sign on both of these. X equals 48. Last one before we do more. 5 over 2 distributed into x plus 3 equals 10. Now, you might say, oh, let's fraction clear, or you might say, let's distribute first. No, because if we distribute, that's just going to create fractions on each of these. It's going to be 5x over 2 plus 15 over 2. What we can actually do is, you know how when we have our variable at the end, we can multiply by the reciprocal? Let's do the exact same thing here. Let's ask the question, what's happening to the parentheses our variable is in? It's being multiplied by 5 over 2. What's the opposite? How do we undo multiplication by 5 over 2? Multiply by the reciprocal. Now, the reason this works is because we're kind of doing the same thing as before, where we're just trying to get our variable by itself. Right now, it has something happening to it. Let's get it by itself, even though it's not technically by itself yet. But what we do to one side, we'll do to the other. Cancel, 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 cancel. We're left with x plus 3 on this side. And we got 10 over 1 times 2 over 5. 5 goes into 5 once. 5 goes into 10 twice. 2 times 2 is 4. Great. X plus 3 equals 4. What's the opposite? Well, in this case, let's just ask it a different way just for the sake of getting our mind in different patterns. What number plus 3 gives us 4? That number is 1. Great. Okay, we got more word problems. If you turn the page to 62, we are doing even still. And math is good and all, but if you can't convert it into English, useless. So that's why we got to always practice our English to math language conversion. All right, number 2. A plus 2b divided by 32. Notice that comma. That comma is separating the two things. So let's start with a plus 2b. The comma tells us we're doing all this first. So we're doing it in one piece. So it basically means, just like how a comma separates groups, our parentheses separate groups. And then it says divided by 32. Divided by 32. Bam. Great. Number 4. In hamburgers at $1.25 each. So it's basically asking, what's the price of the hamburger? What's your total price for your meal going to be if each hamburger costs $1.25? Well, if we have one hamburger, it's $1.25. If we have two, it's $2.50. What does that sound like? Sounds like we're multiplying by n. So $1.25 times our number of hamburgers will give us our cost. 6. John's age in Y years if he is 15 years old now. Oh, okay. So right now, John is 15. John's age now is 15. And then it wants to know John's age later. if we add his age and y number of years, an unknown number of years. That's what that y variable means. It means we don't know how many years yet, but we want to know. So if he's 15 now, in in x amount of years later, or in this case y amount of years later, he'll be ... So if it's 1 year later, he'll be 15 plus 1 equals 16. If it's 2 years later, 15 plus 2 equals 17. So what are we doing? We're just adding by the number of years, which in this case is y. So to reiterate, John's age in y years. What the heck happened? All right. So John's age now plus the number of years we're talking about. That's what's going on. All right, that's the word problems. And then you lucked out. Don't worry about, well, I'm not going to do those because we've done plenty of examples like that before. Yeah, so you should know how to do 7 through 20 by now. If not, you can look back on a previous video where I've done examples like that. You know what? Scratch that. I'm going to do it anyway. Man, can't believe I wasted footage on an apology that was meaningless. All right, we're doing it. What am I doing? Evens? All right, speed round. X divided by 3 equals 9. Let's ask the question, what number divided by 3 equals 9? 27. Or if you want to do it the other way, the opposite of dividing by 3 is multiplying by 3. What we do to one side, we'll do to the other. Left with x, 3 times 9 is 27. All right, when we see complicated problems like this, we usually want to ask, can we simplify either side? Yes, we can. Let's do it. We have 6 distributed into 2x plus 4. So distribution, we multiply by each term. 6 times 2x gives us 12x. 6 times positive 4 gives us 24. Equals 3x, can't do anything yet. That negative sign will distribute through because it's basically a -1. -1 times 4 gives us -4. -1 times -2x gives us positive 2x. Remember, multiplying or dividing by a -1 just makes you flip the sign. All right. Now, can we do any more simplifying? On the left, no. On the right, yeah. So 12x plus 24, since we can't do anything. 3x plus a 2x gives us a 5x. We did not touch the 4. Now, we want to get all the x's to one side, so let's move the 5x over. Since it's a positive 5x, we undo it by negative 5x, which is the same as subtraction. What we do to one side, we'll do to the other. These things cancel. We're left with negative 4 on this side. We got 12x minus 5x gives us 7x plus 24. Bam, we recognize these types of problems. 7x plus 24, the opposite of adding by 24, subtracting by 24, what we do to one side, we'll do to the other. These things cancel, we're left with 7x. Negative 4 minus 24, so we're taking even more away in the negative direction, gives us negative 28. The opposite of multiplying by 7 is dividing by 7. What we do to one side, we'll do to the other. X equals 28 divided by 7 is 4, but the negative makes it negative 4. 9x plus 2 equals 7x plus 3x minus 5. Can we simplify on either side? Not on the left, so we'll just rewrite it. On the right, yeah. 7x plus 3x gives us 10x minus 5. All right, we want to get all the x's to one side. This time we'll move the 9x over to the 10x so that we stay positive. 9x, since it's a positive 9x, we undo it through subtraction of 9x. What we do to one side, we'll do to the other. These things cancel. We're left with 2. 10x minus 9x gives us 1x left over. We didn't touch the 5, negative 5. X is being subtracted by 5, so the opposite of subtraction by 5 is addition by 5. What we do to one side, we'll do to the other. 7 equals x. 9x plus 2 equals 4x minus 3. We can't simplify, but we want to get all the x's to one side, so we will we'll move the 4x over. Since it's positive, we'll undo it through subtraction. 4x, what we do to one side, we'll do to the other. These things cancel. We're left with negative 3. 9x minus 4x is 5x plus 2. X is being multiplied by 5 and added by 2. The opposite of addition by 2 is subtraction by 2. What we do to one side, we'll do to the other. We're left with 5x on the left. Negative 3 minus 2 gives us negative 5. X is being multiplied by 5. The opposite of multiplication by 5 is division by 5. What we do to one side, we'll do to the other. These things cancel. We're left with x. 5 divided by 5 is 1, but because of the negative, we know that it's negative 1. No, never mind. We got 3 more. All right. Can we simplify anything? We should be able to. Let's start with our distribution of our negative sign. So 6 minus 2y, since we didn't touch that, that negative sign as a distribution works as a -1. -1 times 5 gives us negative 5. -1 times negative 3y gives us positive 3y. All right, we can pretty much drop the parentheses at this point. So since we technically distributed our positive 1 through already. Okay. And we combine like terms. Yes, we got let me use our colors here. We got our non-variable terms, and we got our variable terms. So combining the squares, we get 6 minus 5 is 1. Combining the circles, we got negative 2y plus 3y gives us y equals 4. What's happening to y? It's being added by 1. The opposite of addition by 1 is subtraction by 1. What we do to one side, we'll do to the other. What we're left with is y. 4 minus 1 is 3. 5x minus 8 equals 4 times x minus 6. We can distribute. So let's do that. We didn't do anything to the left, so we'll rewrite that. 4 times x is 4x. 4 times negative 6 is negative 24. We want to get all the x's to one side. We want to move the 4x over. Since it's positive, we'll undo it by subtraction. What we do to one side, we'll do to the other. We're left, these things cancel. We're left with 24. 5x minus 4x gives us x. We didn't touch the 8 minus 8. What's happening to x? It's being subtracted by 8. The opposite of subtraction by 8 is addition by 8. What we do to one side, we'll do to the other. We're left with x. Negative 24 plus 8 gives us negative 16, I think. And then lastly, we got a long one. Can we combine like terms? Let's use our circle squares. Square our variables. And wait, what's going on there? Is that an x? What did I write? Yeah, that's an x and this is an x. Alright, great. 12x plus 3x is 15x minus x is 14x minus 7, and then we're left with 16 minus 9x. Alright, if we want to get all the variables to one side, we'll move our 9 over, since we'll have to add it. The opposite of subtracting by 9x is adding by 9x. What we do to one side, we'll do to the other. 14 plus 9 gives us 23x minus 7, left with 16. 23 times x minus 7, the opposite of subtracting by 7 is addition by 7. What we do to one side, we'll do to the other. Left with 23x. 16 plus 7 is 23. What number multiplied by 23 gives us 23? I'll leave that one up to you. You can figure it out on your own. All right, that's the lesson. Okay, bye.